My name is Mark Geiger, and this is a productivity update for SimplyAdd. I've successfully migrated the entire stack to Java 25 and Spring Boot 4, leveraging the latest reactive programming and native compilation. Here's the stack. I have my services, vital signs, provider, the gateway, the user interface, which is developed using Angular, using Keycloak. We have the medication service and drug service, which is used by the medication service to do a FDA API live drug search. So, as you can see, our stack including PostgreSQL, Keycloak, and our microservices is running in lightweight, high-performance containers with a near zero idle footprint. The highlight of this migration is our GrawVM native image compilation. Notice the startup time. We'll check started SimplyAdd provider. It started in less than 2/10 of a second. So it says that's less than 2/10 of a second for a full enterprise service to be live and healthy. We can check a couple more. Let's check medication. Medication is less than 2/10 of a second. And we'll also check vital signs. That's in less than 1/10 of a second. So, just to show you that this is not some random result, we'll go ahead and stop. Docker stop. SimplyAdd vital signs. Let's stop and then we'll start it again. We'll remove it. Remove the container. I'll go back to, let me get the, sorry. Go here. We can start vital signs back up and we'll catch the startup time, get the startup time. Get started, and then we'll use started SimplyAdd blood pressure application in less than 1/10 of a second. So there you have it. All right. Our Angular front end utilizes signals for reactive lightning fast handshake with the R2DBC backend. Complex temporal mapping between Java 25 and PostgreSQL has been solved. You can see I'm using Keycloak here. Let's go ahead and log out. Make sure Vital Signs is back up and running. It's back up and running. Cool. Log out. I'm using Keycloak for the identity provider. By doing that, we've moved to a fully stateless security model. When I commit a record, the backend doesn't need to look up a session. It cryptographically extracts the user's unique identity directly from the JWT subject. It's secure, scalable, and keeps our response times incredibly low. So let me go ahead and log in here. And there we have it, logged in. And just to give you an idea of what the code looks like for using the JWT subject. This is the vital signs record here. If we go to the controller, you can see here. So when we save a record, it's using the JWT subject to for the provider identity, for the identity provider. Okay, so our Spring data auditing logic immediately captures the change, updating the last modified timestamp while preserving the original creation data. So if we go here, just take a peek here at this. So this was last modified, updated on February 6, 2026 at 6:44 p.m. That's Eastern Standard Time. So if we want to edit this record, so we'll update this. Fun updating vital signs when the ratings are great. That was updated at 9:40 a.m., which is 9:40 a.m. Eastern Standard Time. And let's get the record here. This is record number 4. If we select that in the database, I'll just reuse this where ID equals 4. Oops, sorry. Equals 4, right? There we go. So this is created by ID that we was taken from the JWT subject, and this is the UTC time, which is a universal tracking time that we store in the database. So this is at 2:40. And let's go back. Sorry. Where's test at? There we go. Let me go back. I lost it somehow. Okay, so that was at 2:40. This is the record that we updated earlier. That was at 9:40. So UTC is 5 hours ahead of EST. So it's 9:40, 10:40, 11:40, 12, 30, 41, 42, 40. Says it's perfectly accurate. All right, now one other thing I wanted to demonstrate is I added a drug service that can be used in the medication service for executing a live drug search. So we'll demonstrate that now. Actually, let's do this. Okay, I'm not going to delete it yet. We'll go ahead and edit this record. So this is Zocor, this is our, Losartan, 50 milligrams. Let's reduce the dosage here. So if you go to the edit medication page, go to the live drug search form, and search for that drug. There's one that's a dosage was 25 milligrams. So let's go ahead and select that. You can see it automatically updates the the edit medication form. We can try another one. That's 50, 100. Let's see. We need to do a little diet and exercise. And you can see here it went to the 100 milligrams. Let's go back down to 25. There's the 25 milligrams. This comes straight from the FDA website's API, so it doesn't affect the performance of SimplyAdd whatsoever. So we'll go ahead and update that. And as you can see, that updated to 25 milligrams. And if I wanted to delete this, let's say we did some diet and exercise and we're taking off of the losartan, we just delete it. And that gets deleted in real time. One other thing I wanted to demo is our quality gate. This is our BDD step definition class using a custom dispatcher pattern to bridge Selenium with our Spring context. This is pretty cool. So first, another thing is I'm using test containers. So for our unit test, rather than hitting a live database, this basically spins up a PostgreSQL database and then removes the database when the test is done. We'll go ahead and run this. This is our unit test. So it's going to spin up a PostgreSQL database here. There we go. Container. That was fast. Looks like that passed. 3 tests passed. Cool. Yep. Test containers. Very cool. Right here. And then I also have a end-to-end test set up using Cucumber and Cucumber Java. And one thing I wanted to point out is for this application, it uses one step definitions class, which is set up for reuse, to many steps classes. So let's go to not our UI, to our Cucumber. Sorry about that. So this is my feature file. This is a steps class. We're using Spring Boot's context to map the feature file to the actual steps class, which has the logic that's used to exercise the test steps. So this is the dispatcher. And this is Spring Context class, and these are our step definitions here. So to me, it's easier to have one step definitions class and a steps class for each test. It's just easier to maintain and is efficient. So let's go ahead and run this test. You'll see a browser spin up. And the test runs the browser to add a vital signs record. Logged in using KeyCloak. It's going to fill in the form, saves the record, and there it is. And there you have it. The test was run and passed. Let's just take a look at the build results. Oh, I don't have Chrome, sorry. And there you have it. One test pass. That was pretty fast. And basically, this provides, I add logging so that you can execute the test case manually in case something breaks. So you can just go to the test results. You can, and it has the different the details for each step. The URL for the page, the locators for each execution, so that you can manually reproduce the test case scenario for troubleshooting. And that's it for the SimplyAdd update using Java 24.25, Spring Boot 4, GraalVM, native image. SimplyAdd's now faster, leaner, and more secure. One other thing we can just show you. Did I show you that we are using Java 25? Let me do that quick. So this is the POM. This is using 25. Compiler release 25. And then if we go to blood pressure here, we'll go to the build.gradle. We're using Spring Boot 4 and Java 25. So that's it. Thanks for watching.